First things first, do you have a diameter here? Yeah. So as soon as I notice that I have a diameter, what I like to do is I like to draw the ends of it and draw my half circle so that way I know how many degrees there are. So I know that from RQP going around, that's 180 degrees. So I draw my diameter, and I know that from here to here is 180. Okay. I followed through on that, and that gets me here. Okay. When I get to that, if I follow the 50 and I work up to the arc, if I work up to the arc, I have to double it. Double 51, what do you get? 102. So that means that this arc here is 102. Well, that is part of the diameter. Subtract, you wind up with 78 there. Then you go backwards in to this. And again, you wind up with half of 78, otherwise known as 39. That's a tough question for being the second one on a worksheet. There's multiple parts about going through it, okay? Are there other ways you could probably do it? I'm sure there are. But that's the way that I saw it. Okay? Let's see, that one was the first one. Okay, I think when you grab that sheet, the second page is gone off it, right? Just one side? Okay. Let's see. The other one I've had a ton of questions on so far was 3.
You did number 1.
What's that?
You did number 1.
Yeah. In 3, again, you have 2 quick steps to go through. You have 2 quick steps. You know that YW is a diameter, because it appears to be, which means X has to be a right angle. Since this opens to the 60, there's your 30. What's left?
60.
In 5, you have quadrilateral, which means your opposite angles are always going to be supplementary, but do you need to use that information here? Not really. I mean, you could. Okay? It doesn't really get you very, very far. What I would say to do here is notice that your 108 opens up to the arc here, here. So that whole thing would be double the 108, 216. The whole thing is 216, and this chunk is the 96. All you gotta do is subtract it out. I believe you wind up with 120. That sounds right. Okay. That's one way people have done that. Another way you could have done that is to use the supplement. I think it takes an extra step. Remember, X and L would have to be supplementary because they're in a quadrilateral inside of a circle. So X has to be 72. If you followed that one out, you'd wind up with 144. 96 and 144 gives you 240. How much is left to complete the circle? 120. So you'll see as you go through these things, there's going to be multiple ways you can go about solving it. It just depends upon how you see it. Okay? For some of these, there can be extra ways of going. 7 is like that also. In 7, and if I'm skipping over one of them, let me know. I'll be more than happy to go through it and show you guys, because I've been seeing a lot of ones like 6 and 8 have also been, people have been screwing them up. What I see here in 7 is that it opens up to there. So it has to be 210. 210 and 78 is 288. And then how much is left to get you to 360? We got 72. That's the easiest way I would think of it. Another way people have done this is, again, since they're opposite each other, this has to be 75, which means this angle here has to be 150. You can go that way as well. Either way works, especially when you have quadrilaterals. Let's see, what's it? 6 and 8 are kind of the same problem. Huh? What? 6? Huh? Get what? Get what? 7? It's 6 plus 1. I was messing with you, Becca. I was going to go back to it. All right. Number 6 and number 8 are very similar. One thing that people tend to forget is that when you see a diameter, it cuts the circle in half, which means you have 180 degrees then from end to end. So if I'm looking at number 8, we good, Becca? Yeah. When I'm looking at 8, I have Vx as my diameter. So that much of the circle is the 180 degrees. Well, the angle at CVX, when you follow that through, opens here to this arc. So you double the 49, and that gets you 98. What's left to get to 180? 82. Oh, excuse me. When you go to 11, again, the easiest thing that I see is that you could use your opposite angles. I could use my opposite angles. I know that this has to be 80, because these guys have to be supplementary. If I follow it from here to here, that whole chunk has to be 160. If I subtract the 74 from that, I believe that gets me, is that 86? Yeah. Okay. That gives me 86 to here. And then you can follow 86 to 70, is the 156. Then you go back up, and that's 78. That's one way to do it. The other way that you could do it would have been working your way out from the 100. So that whole chunk has to be 200, which means if this part is 70, this is 130. So then you would be able to subtract out, figure out what was left here, and you've got your 86, and then you can figure it out from there. Okay? Really depends on where you're starting, what you perceive to be an easy one to start with. Okay? Bless you. 9 is just like that. To me, I see this one as the 83 goes here to here. So that has to be 166. So that gives me my other chunk then again at 80. Okay. If I add up 80, 80, and 86, that's 246, if I'm not mistaken. Subtract that from the 360. Leaves me a 154. Oh, I'm sorry. How about 114? Whew. Thought that seemed a little high. Just a smidge. And then our angle hits those two. 86 and 14. Is that 200? Yeah, so that's 200. So that gives you 100 for here. Which makes sense because 80 and 80 is 160, which means the other side has to be 200 in order for it to be a circle. Aside from going through the algebra ones yet, are you okay numerical, or is there any other one of the numerical ones you want to look at? Because it's kind of what we're trying to stick with here. We got a little bit of a couple of goofier ones today to try. You okay? Algebra, sorry. Numerically, are we okay? Working back and forth? Okay. Let's try the algebra one then. I hope so. 13 should be pretty quick. You're just adding those three parts up instead of equal to 360. Did we do 14 together yesterday? Yeah. I thought so. 15 and 16 are very similar insofar as that they set up pretty much identically. Remember, when you are an angle, when you're the angle, you double to equal the arc. Okay? So if I double the 8x and 17, 16x and 34 has to equal 6x and 8 and 11x and 16. Let's see, so we get 16x plus 34, 17x and 24. Subtract. And then you had to find the angle, angle L, so BLK. 80 and 17 is 97. Is that correct? Don't forget, when you have the algebra ones, it's usually making you go back and solve for a specific piece. Okay, so you got to make sure you go back and find that part. 16 is the same thing. When you move yourself outward, double it to equal that. You'd have 46x minus 4. Combine those two out, what is that, 54? Subtract. Whatever. What did I do? 40. That's a what? Hi. I was gonna say, why did I get? That's not gonna work. All right. So subtract and add. So you have 2x is 8. That's much easier when it works out cleanly, isn't it? And then substitute. Honestly, the biggest things you guys are going to screw up here are when you have the numerical ones that look like numbers 12 and 8 and 6. Those are the ones you guys always screw up because you have to do multiple parts to get yourself to go. The algebra piece usually isn't as bad. Okay. So let's look at some more of the algebra ones, some more of the trickier interior. By too many. All right, so let's take a look. Let's see. Let's start with 2. Once again, you've got angles and arcs. Yes, sir. Oh, we're back in. Sorry about that. Easiest thing to do, you try to figure out where to start here. You've got 2 arcs, you've got 1 angle. If you look at the arcs that you're given, that arc MN doesn't have its own angle that runs into it, so you'll have to add some other arcs together. So the easiest thing that I see is to take the 95, and since that one follows out here, what does that arc become then? When you have the 95 as the angle, you just double it to get the arc. So if you double 95, what do you get? 190. Okay? Which means this chunk has to be 110. Okay? Now, as you're going around here, we know that we have from here to here is 190. Add 70 to it, you're at 260. Yep. Means what's left of the arc of ML? 100. So utilize little bits of information, the angle. As the angle moves out, you double it, that gets you your arc. And then just start working around the circle. Because now, you're just tracing. What do you get for your angle? 90. There you go. Look at 6. Remember, things that appear to be diameters actually are. So do you see a diameter here?
Yes, sir.
QS gives me a diameter. If QA is 64, what's left for SA then?
160.
Good. Trace through. Angle's half the arc, so it's half of 160. Let's go to 11. Again, what happens sometimes, there's more than one way of going about these types of problems. To me, what I think might be the fastest way to do this one might not be what you guys think is the fastest. So, what do you know about opposite angles in the quadrilateral when they're inscribed? Not complementary. Supplementary, yeah. Okay. I apologize. I swear I thought you said complementary. My bad. So what's the supplement to 116? Then you work your way out. If you double 64, you get 128. Sound good? Okay.
So if this whole chunk is 128, this portion of it's 50, that leaves you 78. To me, that's what I think is the quickest way of going about it. Other people keep asking, well, why don't I just go the other way? And if that's what you want to do, that's fine. Because if you go out this way, if you double, you get 232. 232 and 50 is 282. Subtract that from 360, and lo and behold, you still get 78 if you math that correctly. Okay? Again, it depends on how you perceive it to what you want to set it up to do. Okay? If you do it correctly, you still get the same result. Number 9, this is the case of the of the floating around angle measurement. Not exactly quite sure where it's at.
I think that's what I meant.
That's what I'm saying. To me, that makes the most sense to place that there. So I would place the 37 here at the vertex of the W, because if I do that, you'll notice that you've got that V some letter here. It's going to minimize Vx as a diameter again. So if you trace this one back, if I double the 37, that gets me to 74. And I know that Vx is a diameter. So to get back to here then, it'll be 106. Okay. What's that?
Those are floating, those are...
Let's try the algebra. Look at 17. Again, when you start doing the algebra stuff, a lot of times it's not just solve for x, it's solve for x and do something. In this case, you have to figure out what the arc of EF is. The CUDA stuff, they like to put negative values first, no idea why. But again, you have an angle and you have 2 of the 3 arcs. What do you do to that angle to make it an arc? So if I double 9x and 2, what do you get? You have 18x and 4, 17x minus 1, and a 16x, so that equal to 360. 18 and 17 gets me 35. 35 and 16 is 51. And 3, I believe that's correct. And now you're at a 2-step equation. What's wrong, guy? You might cross that on me there. How many degrees are in a circle? Do you see it? Is there a diameter? Yeah. Remember what I was doing here is I just brought that one out to get, because I had the 3 arcs going all the way around the circle. Okay. And then you wind up subtracting and dividing. I believe you get 7 if I'm not mistaken on that one. Look at number 20. This is another one of those cases of the floating variable. And as I kept looking at this one, for a while, it took me forever to figure out where the heck they were pointing at here. If this was at angle E, could you do the problem? If it was the 41x minus 1 was at angle E, could you do the problem?
Yeah.
Well, if you did, if it was there, that's telling you to go that direction. You still don't have all of the circle. Correct, because it's not a diameter. I don't know about this piece here. So as I kept trying to figure it out, I realized, oh wait, it's supposed to be here at G. Okay. If the 41x minus 1 is at the angle G, isn't that on the circle? So that angle opens up to touch the arc of EF, doesn't it? So what would you do to this angle to equal the arc? Double it. So if you double the 41x minus 1, you get 82x minus 2. And then it maths rather cleanly. It was just one of those, I guess the only way I could have fixed that is if these pictures were a lot bigger. But that would just waste more paper. Okay. Other than that one, I think everything else works itself out rather cleanly. So, knock this thing out. All right, we'll collect this tomorrow. What we'll do tomorrow is we'll start doing the review stuff for all this. I thought about doing the quiz stuff. Do the quiz Thursday. Then I realized that I think they're doing some science testing. So there's some people that are gonna be out moving around. So we'll still wind up quizzing on Friday. We'll be fine. We'll have to test then. We'll probably test then on Thursday, so we have a buffer in case anybody's absent on Thursday. No big deal. We'll just have to bum rush through a couple of things. Okay? I think what we'll do Thursday is the equations that we can get that in real quick. That's a good half day. Yes, ma'am. Okay, go ahead and finish this one out, collect it tomorrow when we come in, and then we'll do the sort of new stuff. Make sense? Is it left? I was thinking oh well. Makes sense. It just sucks.